Yes, ma'am.
Yes, ma'am.
I would like to welcome our chief guest here, Mr. Mahesh sir. Sir, thank you for this time. I know you're having a very busy schedule and it's too early for you also. And in spite of that, you're here to provide the essence of soft computing to us. And I can see there are a large number of computing brains here in the form of students and teachers waiting to get the essence from you and utilize it in the best way. When I say essence, it is always the best part of anything, like the essence of rose, the essence of orange. And at the same time, it is available only in a small amount, in a minor amount. But the effect of that essence is vast. So similarly, soft computing is a very vast field, and I know you can't put all the information in this platform, but we are here to get the essence from you and utilize it in the best way. And in olden days, we would have heard our grandparents or our ancestors say, "இது இருந்தா நல்லா இருந்திருக்கும், இது இருந்தா நல்லா இருந்திருக்கும்." All that this and that's are now available in this world through soft computing. To make my point clear, for all the viewers here, I would like to mention few fields where this soft computing is applied in our daily life. Medical diagnosis, even cancer diagnosis, and in any other field of medicines also, soft computing is playing its major part. Weather forecasting and artificial intelligence. Most of us would have wondered. We would have we talked about a particular topic to our beloveds or to people around, and when we try to Google regarding that, all the points that we expect will come forth. That will be given as priority. And I remember my kids saying, Mom, someone is overhearing us. See, I can see whatever we spoke in Google. All these things are related to artificial intelligence, if I'm not wrong, sir. So all these are happening only because of soft computing and handwriting recognition. Handwriting recognition plays a vital role in all fields and in all sectors. And recently I saw an app. There's a Chinese menu card, and when we keep our phone with that app in, while as if screening that menu card, it is totally translated into English, just in a fraction of a second. Again, here soft computing plays a role. And consumer appliances, this coffee day coffee maker, and all these automated dishwashers, rice cookers, everything has its part in soft computing. And architecture. In fraction of a second, we can have our dream house in front of the system. There is an architecture working inside the system and providing the entire sketch of what is in our mind. So these are just few examples of soft computing. And maybe after today's search session, we'll get to know in what all fields we can spread this. We might even think, okay, all this is because of that two words of computing. And again, coming to communication technology. Both these words are separately familiar to us, but when we put that together, in all fields that communication technology like social media, Instagram, Facebook, Twitter, blogs, most of them are earning through blogs. They present the most silliest topic, the topic that we come across in our daily life, but the initiative that they have taken to prepare a blog and put it in attractive words makes them earn. Even for the most silliest topic, they have millions of viewers. It depends on the way they present it. They are earning for their initiate to present their words through blogs. And similarly, live videos. There is always a saying, even the worst in the world will have one positive aspect. Likewise, in this pandemic made us feel the importance of communication technology. I can have seen most of them have attended all the good happenings in their house and even the bad happenings like funeral only through live videos in this pandemic period for the past 1.5 years. So they would have felt that phone or that laptop would have been their, what is it, uh, feeling expressor at that time. And many conferences by even our webinar now is a good example of communication technology. So there are a lot more applications. And again, we are waiting to know that all these things. And I'm sure, sir, we all are here with a very eager initiate early in the morning to get the essence from you. And there is always a saying, even one valuable information is equivalent to a crore. And I know here, and I can understand that you are here to transfer many crores to us. Thank you, sir. Thank you for being here and welcome. We'll continue the session, sir. Thank you.
On behalf of our computer science department, I wish our principal ma'am a very happy birthday.
Happy birthday, ma'am.
Many more happy returns of the day, ma'am. On behalf of
Thank
our
you, ma'am.
Computer Science and then Computer Application Department, we wholeheartedly wishes you, ma'am. Stay blessed forever, ma'am.
Thank you, ma'am. Thank you so much.
Kindly accept this speech, ma'am.
Kindly. Thank you. Thank you so much.
Excellence is not being the best, it is doing the best. Now I request Dr. P. Pandichelvi to deliver her chief guest address.
Good morning to everyone. I extend my warm welcome to all dignitaries, faculties, students, and participants at this conference. First of all, நமது மதுரையின் மைந்தர் டாக்டர் திரு மகேஷ் அவர்களை நான் வரவேற்கிறேன் நமது கான்ஃபரன்ஸ்க்கு. And it's an immense pleasure in introducing our chief guest, Dr. Mahesh. We are working as a resource associate at German Climate Computing Center, Hamburg, Germany. He is a dedicated technologist and an eminent person with research experience of 8 years and 3 years of industrial experience. He too excelled in the academic service in computer science discipline. His passion on research and academics elevate him as a gem in various fields, and it is this which brought him here. He is none other, our native person from Madurai, who is shining and fitting his steps in other countries and excelling all over. Let's all have a delightful session with him. He's here to nourish us with the major area of machine learning a walkthrough. We all welcome you, sir.
Now I request our chief guest, Dr. R. Mahesh, to start his session.
Okay, yeah. Um, First of all, good morning to all. And today is a special day. Warm my happy birthday wishes to Kalpana Madam. Uh, Thank you so much, Pandishelvi, have give a brief and a good introduction about me. Today I'm going to share something about how much things I know about machine learning, and maybe this presentation would give the brief introduction about the machine learning and give one overall view about this. So I'm going to share my screen now. Okay. Okay. Could you able to see my screen?
Yes, sir.
Okay, fine. So nowadays, the word machine learning is one of the key term or the fantasy word we are using in digital world. Wherever you read newspapers or read articles about business development, they are saying we are going to implement machine learning. So our the capital amount increases because of we use machine learning concepts and methods. and we generate large amount of data. We analyze our business data and gain more information about customers, and we deliver fantastic output. So these are the articles we are continuously reading in newspapers, and policy makers and predictors, they are saying machine learning is going to rule our digital world in forthcoming next decades, 2 or 3 decades. So we may get a great opportunity to see how the machine learning going to impact in our daily life in a positive way as well as a negative way. So this presentation might be give a overview of machine learning. I'm not going to give a technical details or a technical explanation about a particular kind of techniques in machine learning. So the thing is how we could see the machine learning concept, in which way to use it, and how the current industry is marketing the machine learning concept. What is it actually real status behind it? It's little bit different now. Actually, the thing is different. They are simply marketing the machine learning concept. No, so if you have if you don't have the mathematical skill, don't worry. We are the people to give a training in training to learn machine learning concept. Some places they are saying we are having lot of packages. I mean, some companies would say like, we are having lot of packages, use the packages and you predict your business results and improve your business. So these are some glittering words we are hearing from surround us. So the actual thing is, then I mean, end of the presentation, I'm going to explain about what is the actual thing is behind the machine learning. What are the important skills we should learn? So let's start first thing. So what is machine learning? So earlier, I mean, 2 decades before, or I mean, earlier, we don't have the concept, we don't have the term machine learning. But recently, last 10 years or from last decades onwards, we are using the word machine learning. And also sometimes we simply say without understanding the concept of artificial intelligence, oh, AI is going to rule the world. The AI is going to occupy the factories and places, and is the key factor of reducing it increase the unemployment things. So we are simply saying, but we don't know what is actually we are not get the clear information about what is artificial intelligence and what is machine learning. So machine learning is nothing but a subset of artificial intelligence. So before we go to before we going to explain the machine learning, we should know about artificial intelligence. Why do we say the artificial intelligence? So before the machines, I mean the machine era comes, we use only human intelligence to do our daily routine things and do our plans and policy things. We make it through our human knowledge and human intelligence. So then our society is moving to do our work with the dependency of machines. Nowadays we are we are doing our work by machines. So now machines are ruling us. So in this case, the another term is artificial intelligence. So the machine learning is a subset of artificial intelligence that enable a system to autonomously learn and how to learn by using algorithms and mathematical concepts mathematical without need to write more programming. It's a kind of classification of the, what is it? So how we can say it's a classical programming. So by feeding it large amount of data. So when the machine learning concepts apply and make it as reliability, when we feel the reliability of machine learning, so when we use large amount of data, we could feel the real how the machine learning works. If you use small amount of data, the normal the class, I mean, the vintage programming concept is enough to do the simple process or small amount of data. When we use large amount of data, then we could feel really how the machine learning works. So the thing is how it's differ from human learning and machine learning. So human learning, we know already. The thing is sense organs are plays key role to acquire knowledge, and we gain more experience and we store it in memory cells. Not only from gain knowledge by themselves, but also we gain knowledge from to other people who are sharing to others. But it is not the way how the machine learns. So machine learns by training the data using mathematical theory. So the machine gets something from training the data. So what the machine gets, does the machine have memory cells? The machine doesn't have anything to store inside. Maybe its memory, I mean the memory space is only for store the data. It does not store the execution process. So where the machine saves the prior knowledge of past event. So these are the magical words we think about. These are the magical words. It's give a confusion about what is machine learning and the memory patterns. Actually, these are all come under simple mathematical concepts. If you know mathematics concepts in clearly, then you can easily understand what is learning and what is train the data, how to calibrate the data, and what is the data convergence. So simply I explain here machine learning equal to calibrate the machine, and calibrate the machine is equal to it's a data convergence. Once you train the data and converge into one straight, converge, the curve is converged, then the machine has calibrate. The machine has learned something and it's have some posterior knowledge about the probability of data. Once calibrate the machine, then if you give the data, then it produce some results, and we validate the results, and we can do some interpretation. So next thing is how human learns. So still the scientists try to understand how our brain works. We don't know what kind of algorithms we are using to understand something, to understand by view, to understand by hearing, understand by sensing. We don't know actually, but the common, for the generic way the scientists say, the human understand all the things and keep it in memory in the way of patterns. So I'm taking one small example. It's a car driving model. So when we drive a car, or when we learn to drive a car, how our brain works. This is my guess, and also maybe we take it as an assumption. So when we drive a car in 20 kilometers speed, how the components of the car works. So the brake pressure, accelerator pressure, and clutch pressure. And 100 kilometers, how the components are working, how much pressure we, we give to drive the car in stable way. And when we stop the car, how the pressure is working, how the steering angle is working. And when we stop the car in slow way, how the steering, how the brake, accelerator, and clutch pressures are working. Let us take an example. The pattern number 4, steering angle. It's simply is going to some degrees, and pressure. So there is no pressure in the brake. that accelerator pressure, we reduce it from 15 psi to 100 and 110 psi, 15 to 10, 10 to 0. And clutch is 0 pressure. So this is the pattern number 4. For stop, no pressures in the brake, no pressure in accelerator, no pressure in clutch. So this is the pattern number 3. For 100 kilometers, no pressure in brake. We are not giving the pressure in brake. That's I'm saying. Technically, I'm saying. So next thing is accelerator pressure is highest. We are giving a high pressure, more pressure in accelerator. So it's move fast. So the 20 psi. The clutch also 0 pressure, no pressure in clutch, and 20 kilometers, and the pressure is very less in accelerator pressure, and brake is 0 psi and clutch is 0 psi. So these are the 4 patterns. So when we drive a car in the traffic condition, our mind is automatically picks the one pattern, and the pattern it fits our body component and deal with that components and calibrate it, and we fix the speed. So like that, so the human memory is the pattern which could be used in terms of route condition. So we have we store all the things, we stored our learn things, everything in the way of patterns. So we use the pattern and we perform how to drive a car. But how the machine learns car driving model, the same condition. So the machine learns in the way of take the large number of patterns, not from the 4 patterns. It's many probability we use many probability conditions, or we use any other techniques to generate more patterns and calibrate the machine by using some mathematical concept to understand the machine understand the period probabilities or likelihood probabilities, likelihood condition. These are the things it checks and finally calibrate the system. After that, once it's calibrated, then apply into the real conditions. Then the machine become an autopilot of the car. So this is the general idea of how the machine, how human works, human learns, and how the machine learns. These are the 2 different things. So I'm in every slide I emphasize about mathematical model. So the thing is, the students, how currently they are marketing about the machine learning, they are not give a more focus on mathematical model. Actually, the mathematical model is a backbone of machine learning. Even you are a programmer or even you are a software engineer, surely you should know about the mathematical model. Then only you could able to interpret the data, what really you are doing. Maybe this mathematical model, I given small, brief introduction about it, how much the mathematical model involves in the machine learning. Next thing is, generally we have a confusion. About what is artificial intelligence versus machine learning. So artificial intelligence, it's a technology which can create intelligent systems that stimulate human intelligence. So what are the techniques, what are the concepts are come under artificial intelligence? Fuzzy logic. So many software computing techniques is there. Neural networks, genetic algorithm, code optimization techniques, ant colony techniques, bee optimization, bee colony system. So some nature models which gives the resemblance of human intelligence. So we take the model from nature and we adapt into the mathematical model. We change into mathematical model and apply into the program, and we get some results. Most of the results, it shows the approximation. It's deliver the result in approximative way. It's not a accurate way. The machine learning is little bit different than artificial intelligence. It's a subset of artificial intelligence, which enables the machine learn from past data. So the learn from past data, this term is always, we get a confused how the machine learns. So when we explain about the mathematical model, then you could understand really how the machine learns. So which enable machine learns from the past data and experience without explicit program. That is the difference between artificial intelligence and machine learning. So the next thing is, before we start before we start to use machine learning, why we need machine learning? Why do we need machine learning? So already we are, already we are using computers in a pocket model, in a pocket size model smartphone. So we are using more high computing resources in a compact way. We have in programming. I mean, we are having how we can say, enough number of programming languages to do a computation, and more algorithms, more mathematical models we have. Then why do we need machine learning? So we are doing it already in classical way. So the classical programming way, really it is not sufficient in in future era. These are the questions is rise. These are the questions are rise when we ask about this question, why do we machine learning? But actually the thing is, the the thing is, in machine learning concept, we are going to use some classical mathematical models and methods. But why? So how we are going to use the classical mathematical model? How we are going to use the classical algorithm? So those algorithms is not discovered or not invented in the recent past 20 years, past 10 years and 20 years. Actually, those algorithms which have, uh, I mean, uh, developed more than 50 years back and 60 years back, 1914, 1910, 1920, sometimes 1870 or 1800, 18th century, 19th century. In those periods, how when they create the mathematical models, those models we are going to use it here in machine learning. But why do we need this in different form machine learning? Because nowadays we are generating large amount of data. It's more than 10 petabytes per day. So it's tentatively I'm saying 10 petabytes per day, and handling large amount of data is very complex. We are facing this issue now, and earlier we have only uh, we have how we can say, we have less very countable number of data types. Nowadays is more than structured, unstructured, semi-structured, very large number of, more number of data types we are using now, variety of data types we are using now. So we don't know how to couple it on structured and unstructured, how to extract the information from structured data and unstructured data, how to do the hybridization concept. So these are the challenges and issues we have when we use large amount of data. So actually, the core concept is why we are using the machine learning. We are extract some knowledge from large amount of data. We are gain some things. We are generating some rules and apply it, and extract the data which is going to use our business need. That is the main reason why we move from classical programming to machine learning concept. So efficiency current, how much efficiency we have now, it's not enough to do business or decision making in large scale with minimal resources. So these are the four points, the key points. It's helps to understanding why we need machine learning techniques. Next things, what are the applications? Image recognition, speech recognition, and traffic prediction, self-driving cars, product recommendations, email spams and malware filtering, virtual personal assistants, online fraud detections, stock market trading, medical diagnosis, automatic language translation, robotic intelligence, climate science. Yeah. So these are the applications. But in earlier stage, still now we are using the classical programming concept for these applications. But the main problem we have now we are generating large amount of data as images. We are upload more than per day lakhs of 100,000, 200,000 images we are uploading in the Facebook repository. We are downloading many images. We are using the image recognition concept in our daily routine life. For example, in traffic signals, in shopping malls, and for using the image recognition for authentication, for authorization, for speech recognition. We are using virtual voice assistant, traffic prediction. We are using Google Maps to find the traffic, which is the where we have the more traffic on the road or air traffic, and how we can say, we get the more information about on the road, how much distance we have and how can reach there and how long it takes to reach there because of the traffic, and these are the things. And self-driving cars, now the future era is going to implement the autopilot system. Already we have in some high branded cars, BMW and something, BMW and Benz, and the Tesla is one of the branding company, car brand company, which they are going to introduce self-driving cars. Next thing is product recommendation. This product recommendation concept is ruling us now in the way of uh, using our gadgets in smartphone, Amazon, Netflix, Flipkart, Facebook. So they are using some techniques to understand our behavior, understand the customer behavior. They get more information from our app and apply some machine learning algorithms and give the recommendation based on our wish, what we are surfing frequently. So what are the products we purchased in last 2 months, and do some analysis and produce and give some product recommendation based on our behavior in digital world. What's the behavior? What's our behavior in digital world? Based on that, they are doing it now. And email spams and malware filtering. This is a little bit technical in network security. We are not more aware about that because it's technical things. Other things we know, it is common. These are all above points are our it's rule in our daily life. But email spams and malware filtering is a little bit different than the common thing. So they filter they trace the network packets and find the intruders, find the intruders and anonymous mail communication and online fraud detection and stock marketing trading to understand the fluctuation of markets, and study the previous stock, how we can stock trend pattern, understand this previous stock trend pattern and apply the previous things and to predict the future things. And medical diagnosis is also nothing but the image recognition concept and automatic language translation. So Google has invested massive amount of, allocate the massive amount of budgets uh, to in this domain for automatic language translation. We have already, actually here I'm surveying by using Google Translate app, German to English and German to Tamil. I'm using this. So more than 50 languages are supported. So in this case, they are using machine learning and robotic intelligence. And maybe after this conference, maybe you could search in YouTube Boston University robotics. You search in Google Boston University robotics. Use this keyword. Then you get an amazing video how the robotics industries is growing very fast. They are going to use defense. They are going to use already they are using in industries. They are going to use it in daily life. So in future, maybe the robotics rule over the world, even in digital, not only in digital, not in as also physical, and also the climate science. Recently, I'm happy to say here in three great people share the Nobel Prize, who they are achieving climate science. They are they develop the models, they develop climate models to understand the physical parameters they are applying nowadays. We are applying machine learning techniques to understand the climate circulation, I mean atmospheric circulation, to give a prediction about what is the climate, how the climate change is for next 20 years and 30 years. And also we are also submit the report to IPCC. It's very helpful to, I mean, draft the new policies. It helps to business people. It helps to common man to give a forecast for 3 days and next 3 days and 4 days. So these are the vast areas, application areas, which has been used by machine learning. So nowadays, big companies, what are the big companies that are using machine learning? Facebook. The Facebook already use the face detection and recognition algorithm to provide the auto front tagging suggestions. And already we know about that. Basically, we know the Google Assistants and Alexa. These are the two major major product are using speech recognition technology to give some instructions and do some work. Amazon is product recommendation and relevant advertisement rolling they are using, and Netflix, they are also used for product recommendation and users wish lists and understand the customer behavioral studies. Pindrop is also one of the company which used to identify the fraudulent activity over the phone call. And Google Brain take a big steps to create research opportunities in machine learning and natural language processing. They actually, the Google Brain is one of the is a project name actually. It's this project is mainly focused on study. Give an opportunity to study, give opportunity to learn machine learning and artificial concept. They are announced some internship programs and fellowship and open PhD program also. So if you have if you have some basic concept of machine learning, if you have some idea how to do something, then you can simply write a proposal and submit to Google. Maybe the Google welcomes you to do research in their place. And next thing is I'm going to say simple statistics, how the machine learning, the ML concepts going to rule over in future. They are predicting something by using machine learning techniques. So the global artificial markets to predict for next few years reaching 190 billion market value in 2025. So it reached, the AI market side is going to reach $180 million dollars, is going to reach $180 million by 2025. By 2020, China will become a world leader in AI technology. So it takes the 26.1% of the global market share, and 80% of retail executives expects the retail companies to adopt AI-powered intelligence automation by 2027. So from these statistics, what are the points we are getting clearly? So we are going to get more opportunities to get a job in machine learning domain, and at the same time our the daily things, our what are the things we are doing as a daily routine life, those are going to make us automated, and we are going to depend on missionary suggestions and take the decision based on missionary activities. And next thing is statistics, how the current the machine learning concepts which involved in different how we can different point of view, I'm saying, for services, in the way of services. So the 60% of 60% they are using machine learning for extracting the better quality information from the large amount of data, and 40% for increasing the productivity and speed up the process, and 46% for reduce the cost for we are using machine learning, and 31% for extracting more value data from large amount of data. For 30%, for example, in the 30% of 30%, for example, the Facebook gain more information from us, and for extract some valuable information which helps their improvement, business improvement. And 48 percentage of productivity and speed in process, maybe maybe it's most of the things they are using in factories, and reduce the production cost and reduce the other resources cost. Next thing is leading area. What are the areas currently we are using the machine learning concept in? What are the areas we have? 33 percentages of business analytics, and 25 percentage for security, and 16 percentage of sales and marketing. Maybe this 16 percentage maybe rise, it's give a great rise in within next 10 years, and 10 percentage for customer service, and 16 percentage for others miscellaneous things. So the next thing is, what are the challenges we are going to face up? The 43 percentage we have a challenges in to scale up our industries, because already we are following the traditional one, the classic, the classical model, how to scale up into the big things, to using to adapt into adapt the new techniques. That is the one major challenges we have. And reproducibility in ML models. And so now, for example, we are using, for example, let we say this is the version of the mathematical models has some versions 1.0, 2.0. In future, the versions are it's going to come many versions. How to use this version compatibility issues we have and produce the result in efficient way. That is also one of the challenges we have. And how to reorganize, or how to align our organization structures. If you use when if the mission involves more in our in the productivity in the productions, then we should organize some things. Maybe the mass layoff will go, or import many machineries, or import only one within for example, for two big machines, just only one small computers we are going to use it for implement machine learning for for example in our factories. Then how to align it, and cross programming languages and framework support, and duplications it may come, ambiguities will come, so how to resolve it. And others is a miscellaneous of 26 percentage. So the main thing is how to scale up our industries, how to scale up the domains, how to convert, change from classical methods to machine era, classical methods to machine concepts. So next thing is come to point of machine learning types and methods. So there are three types of learning: supervised learning, unsupervised learning, and reinforcement learning. So the reinforcement learning, little bit actually the resemblance of how the human learns, that is equal to reinforcement learning. The supervised learning, when we are a student, how we learn subjects, that is called supervised learning. And unsupervised learning, how we gain more knowledge from the societies, the social behavior, that is that we take it as a unsupervised learning. So supervised learning means when we are as a student, how we learn subject from teachers, when we write the exam, how we perform our exam, learn something from class, and learn some from teachers' statements, and we use the existing knowledge and we write it here. And if any new question arrives from the existing knowledge, we try to find out the new things. That is called supervised learning. So unsupervised learning means even we get many information from many things from teachers and many things from parents' advice, but when we come into the practical life, we face new things, and we face new things. So it is not come under supervised learning; it is come under unsupervised learning. And reinforcement learning in the sense, when we learn something for drive a car, or to understand the machines to how to operate it. So in time being, we we are doing a lot of mistakes. From the mistakes, we improve ourselves, and then finally we learn perfect, and we perform our work in a nice way. So this is the way This thing is equal to the reinforcement learning. So in technically, how we can say, use of labeled data sets to train algorithms to classify the data or predict outcomes accurately. Use the large amount of data sets, past data sets, we trained it and calibrate it. After that, then we feed the new data for prediction. We get the results accurately. The predict outcomes is accurately. So what are the methods are available in supervised learning? Regression, classification, Naive Bayesian model. Naive Bayesian model is also in classification and also it's a probabilistic model. And random forest model, neural networks, and support vector machines. So these are the 6 methods. Actually, these 6 methods now, these are the 6 names are new here. These are the technical names. Here again, I'm going to emphasize here. So when you understand clearly about the mathematical model, then you can easily get it. What are the real things? So regression, classification, Naive Bayesian model, random forest model, neural networks, and support vector machines. These are the 6 things come under supervised learning. And next thing is unsupervised learning. So unsupervised learning is nothing but nothing but to analyze and cluster unlabeled data sets from the from the large amount of data sets to dig something to discover some patterns and cluster the data, classify the data, and find the similarities, find the difference, to find the uncertainty, and do the segmentations in the data. So these are all come under unsupervised learning. So the main thing is here, it's not like a supervised learning because no need here, no need training data here, no need to train the data. This is unsupervised learning. So these are the methods come under unsupervised learnings. K means clusterings, K nearest neighbor algorithm, hierarchical clustering, anomaly detection, neural networks, principal component analysis, a priori algorithm, and singular value decomposition. Singular value decomposition is simply decomposition the data, Fourier transform decomposition. Some decomposition algorithms are come under unsupervised learning methods. This is reinforcement learning. So reinforcement learning is a feedback-based machine learning techniques. So checks the result in every state. Once you run the machine, you check the state, and check the result in every state. If the result is satisfied your requirement, then it's fine to move on to apply into the real data. Otherwise, you change the state and can again redo the learning process until you get good result. That is the reinforcement learning. So deep learning, the thing is deep learning, CNN, automation techniques, and Monte Carlo simulation. These methods are come under reinforcement learning. Many techniques are there, bootstrapping techniques, and generate the sampling from small amount of data. The calibration, machine calibration is also the under part of reinforcement learning. So these are the 3 types of learning methods come under machine learning techniques. So these last 3 slides you might be get more information from our different workshops and seminars and concepts, but still this is the place to I'm going to tell it again. I tell it again here, but maybe somehow some information maybe you get rather than getting information from other conference, maybe getting something new here. Next thing is it's actually now it will come into the next level, deep level. I'm going to explain the classification. Classification is a form of data analysis to extract models to describe important data classes. For if we just think about the data classification, so we're going to classify the data. How to classify the data? What are the classified data we are using in real time? For example, you take simply you can take classify the people educated, non-educated, and educated, and rich, poor, uh, gender, female or male, fruits. You take, I mean, vegetables, you classify the vegetables in different ways. Rooted plants and leaf plants. Another one is, so you can classify the vegetables in different way. Fruits, it's winter, it grows on only winter, it grows on only summer, it grows only on autumn. So you can classify the fruits in this way. Or classify the vehicles, two-wheeler, three-wheeler, four-wheeler. Classify the genders, male, female, transgender. So in our real time, we are using the same concept, but we are not aware about it. When we think about a mathematical model, then we feel a little bit tricky, but it is not. That is the problem we have. So just you understand the mathematical model, how we classify the data. It's very simple. So the classification in the form of data analysis to extract model describing important data classes. To involves dividing the objects, dividing the objects and assigning into one number. It's mutual exhaustive and exclusive. And in the terms means the object must be assigned precisely one class. So the object you put it into one box. You should put it into one box. I mean one class. So the one object should not be in different boxes. One object should be in one box. Otherwise, you should not classify it. You leave it. That is called imbalance classification. We will see it later. And what are the types of classifications? Binary classifications, multi-class classifications, and multi-label classifications. And final thing is imbalance classification. These are the types of classifications. Even we have it in technical term of classification, but these are things already we know it. I'm going to simply give it in a technical way, that's all. The binary classifications involved classify the data in two tables. 0 or 1, simply yes or no. If you classify the data in from the answer just yes or no, so you classify it into two classification. Binary means 0, 1. So you classify data only in two labels, by two labels, 0 or 1. So what kind of distribution we could use it? What kind of distribution we could use to understand the data? Binary data. So the Bernoulli probability distribution is a suitable one to is a common model to use to predict the how real data we are going to classify it. Next thing is, what are the popular algorithms that can be used for binary classifications? Logistic regression, k nearest neighbors, decision trees, and support vector machine and naive Bayes. These are the popular algorithms. These algorithms they discovered when 100 years before, nearly 1920s or 1900, 1910, 1930s. But we are using a classical maths, but in different way, in different form, in different flavor. Maybe it's called as machine learning. And multi-class. So multi-class classification refers to those classification tasks more than two classes. So the variety of classes. We classify the students in variety. Average student, very good student. He is a beginner or intermediate. He is the expert. So different class. So how to classify the data in different classes? And for this, we are using multi-node probability distribution. To understand the data, we use the distribution concept. And these are the popular algorithms, k neighbors, decision tree. The same, you could see the same methods, algorithms. We could use it for binary classification also and multi-class classification too here. So decision trees, naive Bayes, and random forest and gradient boosting. These are the algorithms which come under multi-class classification. Maybe some more algorithms I'm not listed here. And last one is imbalance classification. Actually, imbalance classification is nothing but a classification. I mean, it's nothing but unclassified data. We can't able to classify the data. I mean, for example, uh, when we take large amount of data, we can't able to classification. The type of class, for example, is we have the frequent items are more. Sorry, the frequent items are very less. So unique value we have. At the same time, some values are is it shows anomaly. It shows the anomaly signal for extremes. For example, you take an example of temperature for the month of December. So we have average temperature. We have near 20 to 24 degrees in December. So 1 month data we have for 30 days data for 1 hour for 30 days. So in the data, we can't be able to classify the data, but at the same time, we can be able to extract the data which is anomaly, which is anonymous, or which is extreme. So when the temperature is, we could feel more than 30 degrees on December. That is the extreme event. That is the extreme. That it's a little bit different than normal distribution. It is little bit different than normal distribution. So then for this situation, this kind of situation, we called as imbalance classification. So the type of classification problems I listed here: rare event prediction. So actually now we are facing northeast monsoon. Now we are in northeast monsoon activation mode we have now. So this is the common event. So sometimes we get extreme event in the northeast monsoon. So how to classify the extreme events from for 50 years monsoon data? If we take 50 years monsoon data, how we classify the data which having a rare event? So imbalance classification method helps to do it here. Next thing is, for a simple example, I'm giving how to classify the data, how to classify data in the way of train the data set. I mean, supervised learning. Here there are three attributes we have. Attribute 1 having values S, no, S1. This is the data binary classification. So here attribute 2, it shows multi-class classification: large, medium, small, large, medium, small. And attribute 3, it's like it's continuous random variable. There is no classification here. So these three variables are independent, and the output, what we are going to know about the class. So the attribute of class is binary classification data. I mean, binary classification data type. So we are going to apply some algorithms, learn the models. We understand the posterior probability of combining these three attributes. What we get, find the posterior probability and likelihood conditions, and fix some calibrate the model, and use the test data set, I mean future data set. And we just give the input of three attributes in the machine learning model, and it gives the class value, maybe yes or no, from understanding the pre-year and pre-year probability conditions. So this is the way how the machine learning works in the classification task. So we know already what are the conditions we have. Yes, large 120,000, class no, no, medium 100K, no. For example, here, if the record have no, medium 100K, we simply say the output would come, the class value output would come no. Suppose it comes large, here it's no, yes, or medium, or 120K. So this value, it is not available in the existing trained data. So then move on to find out the posterior probability and likelihood conditions. We calculated, we could use a Naive Bayes algorithm, use Bayes theorem, and find out the posterior probability and likelihood conditions. Based on that, we can classify the data. It's almost 85%, 90% accuracy would give. And example of classification data analysis. in our real-time domains, life science, to predicting tumor cells are benign or malignant. It's the state. We can classify the state of tumor cells. And security, classifying the credit card transaction as a legitimate or fraudulent. Prediction, whether voting, the polling system, and political dynamics, etc. These are the things. These are the topics come under prediction domain. And entertainment is categorizing the news stories as finance, weathers, entertainments, sports, Netflix, our advertisements, Facebook post, Instagram post, and classify the social media users, classify the people behavior. We can add lot of things come under in social media domain, and identify the current trends and future growth, to understand the networks, to understand our friends list, to classify the media user. He is active user, he is inactive user, he is posting, the user posting continuously some sensitive content. So he is a black list user, he is a red list user, he is a yellow list user, he is a green list user. So we can classify here. So many, not only from these 5 domains, more than, we could say more than 30 or 40 domains we are using this data classification techniques to classify the data for future predictions and for their business needs. Okay, now here I am trying to say again and again, mathematical concept is very important for understanding machine learning concept. It's very important. At the same time, we should not be as a pure mathematician to pure mathematics is not essential. It is not a what's it? It's not the great deal with as a pure mathematician. But somehow you should know about the concept, how really the basic ground concept you should know about it. For linear algebra, calculus, probability theory, discrete maths, and statistics. So these are the major the core concept, mathematical core concepts which involve in mathematical learning, development of mathematical learning techniques. So at least we should know about the probability theory, what is called events, what is called posterior probability, what is called prior probability, what is called probability density function, what is called probability distribution functions, what is called binomial distribution, what is called continuity. We should know that, then only we could use the machine learning techniques. Otherwise, we simply use some packages, it throws some results, we don't know what is it. We can't able to interpret it. We can't able to justify it. We can't able to what is the real significance of the output, we don't know. We can't able to compare the existing one, priority one, what is the really it throws, because we can't trace the how we can say trace the changes of data, the propagation of data changes inside the machine learning. We can't able to trace it. So that this is the real problem we have. This is the real problem which real problem which we are facing in, how we can say, in real-time applications. But when we are looking about that the marketing word, like you please come to join a 6-month course, you learn something, you become a data scientist within 6 months, you could become a data scientist in 3 months. You take this course for 3 months. In the 3 months, maybe you could understand the packages, how it is works. Maybe you could understand how to use the packages. But I'm surely saying we can't understand within the 3 months to understand the how the mathematical models involved in the machine learning. At the same time, I'm not give a fear to the people. You should know at least deep ground mathematics. Not like that. I'm not give a fear, but at least we should understand the basic idea of what is calculus, over the differential calculus, when we are going to use the differentiation, when we should use integration, where we are going to use discrete mathematics. In the discrete mathematics, how the graphics theory concepts going to use in
Could you hear me, my voice?
Now it is okay, sir.
Okay. Yeah. Here I'm trying to tell about how the mathematical concept is very important. So what are the methods are come under which mathematical model? So regression analysis, principal component analysis, support vector machine for the matrix oriented problem matters for finding the shortest path to finding some patterns. So these are all design the neural networks. These are the method. These are the concept and techniques come under linear algebra mathematical model. And calculus, differential calculus and integral calculus, data convergence and approximation theories. These are come under differential calculus. So where we are going to use, maybe I could say here. So the principal component analysis, where we are going to use the principal component analysis, when we have the large amount of data we can't able to process it, and we can't be able to find some do some analysis, because then we reduce the dimension of the data. Then we use principal component analysis to classify for data classification. In supervised learning, we could use support vector machines. For design the neural networks, for conventional neural network or any perceptron or backpropagation or some neural networks, we could use we should use linear algebra concept. That is the way I'm going to say here. For regression analysis, if you want to do some regression analysis, it's come under linear algebra. So for understanding the regression analysis concept, you should study about something about what is the groundwork study of linear algebra. You should do that. And calculus, differential calculus and integral calculus, when we understand the flow of dynamics, understand the dynamics, understand the fluid dynamics or thermal dynamics or aerodynamics, to understand how the data flows in one state from another state, the rate of changes and rate of flow and rate of work, the rate of something. When you apply, when you want to do something about do analysis about this categorized data, you should use differential and integral calculus. And if you want to converge if you want to apply the data convergent techniques, you should apply the calculus. If you want to find something, some approximation result, if you use, for example, optimization techniques, we know that Bickham method, dual method, simplex method. These are also some approximation techniques and optimal result. So for this, you could use calculus concept. Then you should, for this, you should at least you should have the basic basic terms and basic theories and for understanding the calculus and probability, finding the uncertainty of the data and hypothesis study, and evaluate the data in probabilistic way, and giving a forecast and giving a prediction and do the prediction in probabilistic way, and understand the data, how the data is sorry how understand the characteristics of data by the distributions. Maybe this data is when we generate the probability distribution, like it is a binomial distribution or what is it, Gaussian distribution, or it's Bernoulli's, it's Poisson distribution or normal distribution. From the distribution, we could understand the data, how it is really there, what is the extreme, what are the percentiles, what is the quantiles. So these are the, when use, I mean, once you move on the advanced statistics level, then you should know really you should know about the probability things. So the probability is also very important. Maybe the probability and statistics are the very big hand to lift up the machine learning, I'm saying. And next thing is statistics. So sampling the data, understand the data distribution, to interpret the data in the way of standard deviation, variance, correlations. Actually, the thing is, we are having many words about the words which is the ripened words. I mean, after the fruit ripens, how we can say it's good to eat, but in the time being, we don't know how the farmers cultivated, how the harvest, the process very hard. Like that here, the machine learning, we are simply think about only the result. Oh, you get the result, you can able to predict it in very fast. You can simply you put some data in the method, so the method throws some output, and the output it's improve your business rate. That is not the deal here. Actually, is going. Actually, we should know the basic idea about what is actually behind this. So standard deviation, variance, correlation coefficient, mean, median, mode. So these are the terms which helps to interpret the data. So you should know, really you should understand about this, and really you should study about that some advanced level, at least some beginner level of statistics, to understand what is really machine learning and regressions, and finding the significance of the data, how significance of our output, significance of our outcome, significance of our analyzed report, analyzed result. For this things, you should know about the statistics concept. So the thing is, from the 30 slides, maybe I could get some information about the machine learning in a common way. As you know, earlier in some conference, some workshop, at the same time I give some statistics numbers, which how much is going to give, how the machine learning is going to impact in next decade. And from the machine learning techniques, we just touch up the what is called classification, what is called the data classification techniques, what are the types of techniques, what are the methods are come under in which techniques, and how the mathematical concept is very much important to understand machine learning. Again and again I'm trying to say here, before you apply some software packages or software packages or tools to use the machine learning techniques, before that you actually what I'm experiencing, what I'm getting experience here, I'm saying the same thing I'm saying to you. Take a paper and write it out, and what method we are going to use, and what is the basic theory, behind about this method, where we should use this method. Sorry, where we should use this method. Really, this method is suitable or not? I'm sorry. Yeah, really this method is suitable or not? So if we get the results from the method from packages, is it reliable or not? We can't able to justify it when without understanding mathematical model. So I'm from this talk I'm purposely telling about the math, how the mathematical telling about how the mathematical concept is very important here. So how do we know it? Because already we how do we put us to learn mathematical concept? We are not a mathematical student, we are a computer science student. But without even we are a computer science student, how we play with our data? So how we write a program? We can't simply use the syntax. We can't use the simply. I mean, we can't use the syntax simply way, and we can produce the result. Some mathematical calculation we are using it. Some mathematical calculations, some methods we use it. So in this case, in subject point of view, we have in the syllabus we have some mathematics paper like numerical methods, discrete mathematics, or mathematical foundation in computer science. Maybe we could add probability and statistics also we have. So I think these are the subjects quite enough to learn, to understand to understand the mathematical model and implement it. Do it in the way of do it in the different way. We call it machine learning. So that is the maybe you would take it at my advice like that. And next thing is, these are the how many points and how many statements we looked at. Now it is not enough to fulfill the basic understanding of machine learning. Some points need to be looked out. Data processing and types. Before you apply the machine learning techniques, we don't know how the data looks. Maybe the data is corrupted, or maybe the data have more missing values. Maybe the data has more noise. So you should clean the data, or you process the data. You should remove the missing values. Somehow you process it and make it as smooth way, which is apt for applying the machine learning machine learning techniques. So data processing is very important. It's also very, very important because the data is going to feed into the techniques that once you feed it and it calibrates it, and it's going to predict the real data. So how much we should give the importance of the data processing. Next thing is how to find the suitable method. So earlier I list out the problems in the way, list out the methods in mathematical concept view. So first thing, you should understand the problem, and then you try to match it, or to couple it, which mathematical model suits to solve this problem. And from this way you can find the suitable technique, and you should validate that the output, really this output is reliable or not. You should know about how to validate it. So some techniques we have, some methods we have. So those methods you should know about it, and way of interpretation, how to interpret the result. You may get some numbers. For example, you give 5 serial numbers. For example, 5 column of numbers, more than 10,000 records. Those records have 5 columns. You calculate 5,000 into 5,000. So that much numbers you give into machine. The machine do something. We don't know what is going to happen inside. Somehow it works with mathematical model, it's going to throw something. But how you are going to interpret the data? You do some analysis from the data. I mean, from the data, you may say like the next 10 years we are going to get a profit more than 100%, more than 20% from now, and maybe in future it's going to happen. The climate change is going to reach two temperature. I mean, 2 degree temperature, 1 degree temperature. It's going to rise up. Maybe how you can predict the data, you can predict it in social behavior, I mean in many ways, but the thing is how to, you should know about how to interpret the data. What are the terms we could use it, what are the technical concept or technical methods, terms, and use it, how to interpret it. Some small, for example, variability, trend, I'm saying these are the trend, variability, how we can say minimal changes, maximal changes, bias, unbiased, warm bias, cold bias, D-trend, long-term variability, data significance, signal of anomaly detection. These are the technical terms to use it to interpret the data. So so these are the points need to look out it. And computing resources. So I didn't earlier I didn't tell about the computing resources. Computing is also one of the major role to play in the machine learning running. We could say it's running because here we are using high performance computing machines. Is nearly around 50 petabytes data. 50 petabytes in the sense, earlier where I was working in that Indian institute, there we have a supercomputer. This is the India number one supercomputer. It's Pratyush. It's named Pratyush. So we simply feed the program in the HPC machine. For example, today maybe we would get the result in next 3 days. Sometimes the long run, we have to do it long run. So because we use the large number of data in TBs, one file, the size of one file may be in TBs and GPs, and produce is more than 10 TB, 20 TBs files, and number of files we get it from the machine. And sometimes we apply the techniques, numerical methods, concepts, and run the climate models, and we get the future prediction results. So when we use large amount of data, we should take it to the account of computing resources, how much we need. So if you have more than 2 GBs and 3 GBs data, you're going to process it. So the laptop, the computing resources is not enough to do it. So then you are moving to cluster machine. So when you use more than 20 TB data and 30 TB data, 30 TB data, so the cluster machine is not enough to do it. Then you move on to HPC machine. So if you are going to do long run for 10 days and 15 days and more dynamical process, more mathematical concepts that involved to process the data, then you move on to next higher level, higher performance machine. So Amazon, Facebook, Google, they are using high-end computing resources. They are using to store and share the data and to learn some things from our data, and they are giving a they are delivering a very great service to us. So these are the points need to be look out. Maybe but the time is not enough to do it here, because if I take the data processing, maybe it may go to 1 more hour only for data processing, data cleaning, data noise reductions, and so some many techniques we have. So next thing is how to improve ourselves through online mode. So we have a lot of in internet, we have a lot of platforms, education portal platforms. We have Coursera, edX, and Udemy. These are the platforms we have. We can We could see how the professors are teaching the lessons, and we could get feel how feel we sit in front of the teachers teach the lesson on board environment, and no need to pay the certificates. Just if you want to just learn, no need to pay money for certificates. If you need certificates, if you want to if you want to be a certified person, then you pay certificate some little amount, then you get a certificate. And the simply thing is, my favorite thing is YouTube education channels. The great institutions, Indian Institute of Technology, ISER, in foreign universities, they're having their own channels. They're having their own portals. They have, for example, the central government have a separate channel for NPTL. In the NPTL is, a bunch of video libraries. You can find it in NPTL portal. NPTL channel about not only the machine learning, whatever you want, you can utilize it fantastically. Simply, it's just for each presentation maybe might be 1 hour or 2 hours, or sometimes it's like a series of episodes you could see there. And that is the best way I'm saying. And tutorial websites, for example, I give only 2 points: tutorial points and W3 schools. And also the great thing is books. So my preference, how I'm learning here, using which mode I'm using things, mostly the books and YouTube educational channels. So these two things are the major, what is it? The major part of the learning. These are the 2 points. One is YouTube education channels, another is books. So try to, use these different modes of learning and improve your skills. And again, I'm trying to say is understand the mathematical concept which involved in machine learning techniques. And simply you just use some benchmark problems, or just you take a paper and you write simple problems and do it, and you can easily understand it. And final thing is, thanks for all giving a great opportunity to share my knowledge here. Once again, and heartily congratulations for your bright future. Thank you so much. If any questions, please ask me. It's welcome now.
Thank you, sir. Participants, any queries? Any queries from participants?
I think students are listening from
I
hall.
have
Is it
a
right?
question. Can I ask?
Yes, sir. Yes, sir.
Okay.
I'm Dr. Keshavamurthy from VIT School of Law. Actually, I'm from a different background. I'm not from the engineering background.
Okay.
And I have one curious question to ask to Mahesh,
Yeah.
Mr. Mahesh. And so that is actually, you are talking about a lot of technical aspects of the machine learning and artificial intelligence. And that was very useful to me actually, especially to me because I belong to different field of study. Thank you for that, first of all. And my question is actually how you can make these algorithms uh, technically responsible for its own act, because you see that the discrimination uh, by the algorithm is very high nowadays. For example, it is differentiating based on the skin color, caste, creed, and all those things. And that is one of the fundamental human rights of any human of the world. that nobody should be discriminated based on those things. What is your opinion on this, and how you can make these algorithms more responsible? And where is the flaws on this particular machine learning, especially? Can you throw light on that?
Actually, can you make sure what I understand, what I get from you? I mean, you're saying about the classification, that algorithm, uh, how we handle the flaws of algorithm which classify the data in skin colors. Is it right? What I am understanding?
Yes, correct. It is discriminatory in nature.
I mean,
So
discriminating here, the word is confused. Little bit. Discriminating in the sense of, I mean, you're saying about the data discriminating technically, or skin color discriminating thing.
now see here, the problem here is this machine learning needs a lot of data, if I am not wrong. It needs so many data, which includes both the personal identifier as well as the social identifier, is it not? Say for
Mm-hmm.
example,
Mm-hmm.
this machine learning is used in criminal justice system to
Mm-hmm.
identify who could be the possible criminals. It's
Mm-hmm.
not that who is a criminal, who could be a
Mm-hmm.
possible criminal.
Aha,
For an
aha,
example,
aha, aha.
yeah, for an example, there was a AI-driven software that is used in US that is called Compass. Immediately after deploying that particular software, it has identified thousands and thousands of black people as criminals, possible
I
criminals.
got it. I got it
Yeah,
clearly. I
this
got
is
it
the idea.
clearly.
This is the idea. Yeah, yeah. Yeah, this is what my question
Yeah,
is.
actually, here, actually, the here, how we could take it this problem, because for example, you said the kind of software. Just we take an example, that software. I don't know about how the software works, but maybe I guess it. So the input parameters, those parameters helps to identify the criminals. That parameters, the values highly have the highest probability, which have which the who having the black skin people. So they set the problem. I mean, how I mean, the thing is, our human interpretation, we purposely feed into that, into the input parameterization of that algorithm. Actually, the machine, we can't able to, I guess the thing is, we can't able to solve it through the machine learning thing is, and we can't able to handle it, because it is, in our view, even it shows the more number of people who are more number of black people, for example, more number of the peoples look like in the same resemblance. I don't like to say the black people and like that. I'm saying that there's some group of people. uh, so the first thing is, our point of view should be changed. Then only we could get that answer from this, because the machine know only the data. Machine only know the numbers. So maybe the past history events, they take it from, like, from, I mean, they process the data from the history events. So sometimes it shows, maybe, or they are doing it purposely or not, or they are creating the different view or not. We don't know the things. The machine works based on the numbers. So maybe once we get the result, we can verify it really it's happened or not. That is also one of the part of data validation, how to interpret it. Maybe it gives the different direction. But the thing is, the machine play with only numbers. So how we give, I mean, the thing is how we give the data to the machine learning techniques, it throws something. So based on the numbers only it's placed, but the view is only our view. We could change our view. Yeah, maybe I mean, 20 years back or 30 years back, 50 years back, we have the common idea about how many, what are the peoples look like, criminals, and the skin colors and tone and heights and the body muscles. Maybe they can classify it, but it's not the good way to classify it now. We know it now, but the existing data having like that, but we should not take it as an account to interpret in this way. That is the point I'm saying.
Right. Thank you. But followed by that, say in case if these kind of interpretations, if we wanted to avoid it, we should come up with a solution for that, right? Technically, because a logical mind can interpret in such a way, contextually it can interpret. But what about
Actually, I got the point. How we can actually now the thing is, earlier we have many mathematical models for doing a mechanical process. Nowadays we are generating more mathematical model for social behavioral process, social behavior model. We collect large amount of data from different social ethnicities and different social people societies, and we collect it, and we do some ground study about how their behaviors, how its behaviors change, how the states are changing in stochastic way. And from the different mathematical models which involve to understand the social behavior, those models helps to solve this kind of problems.
okay, I could understand. And see more or less, if I'm not wrong, we are moving towards from quantitative method of